Okay, so you missed lesson 4.3.1, Stoichiometry with energy. First, there's a table here, and it asks you to look for the information that is missing in order to calculate how much fuel would be needed to move a car using that fuel. Because look, it gives you how much energy per mole the fuel provides, but what it doesn't tell you is, well, how many moles of the fuel are used when a car drives. So that's part of what we're doing in today's lesson is we're using this number with hydrogen, how many kilojoules per mole, in order to figure out, okay, well, depending on how many moles of hydrogen were used in moving the propeller, we can figure out how much energy was actually used. All right, so reminder, you can refer back to lesson 4.1.3 as well as 4.1.2, where we were using the electrolyzers to split water into hydrogen and oxygen gas and then use those gases to power the propeller. So that's what we're doing again, only this time we're going to collect some data. We're going to figure out, if we're running the propeller for 1 minute, how much of the gas in that tube was actually used up, so we can record the initial milliliters. Actually, I don't think it goes up to 20. Let's say there were 15 milliliters, and after it runs the propeller for 1 minute, there's only 13 milliliters of hydrogen gas. Well, that must mean that it used up 2 milliliters of gas in that process. So I'm going to record that data here. Originally we had 15.0 milliliters, and after the propeller runs for 2 minutes, we notice that 2 milliliters of the hydrogen gas are used up. So in class, we did that. Some groups ran a second trial and then calculated the average change. But it was indeed around 2 milliliters. So then, to show our work, if 2.0 milliliters of hydrogen gas were used up, well, we know some things. We know that there are 1,000 milliliters in 1 liter. And according to the information in number 8 from above, there are 24.5 liters of gas in 1 mole. So now we can actually calculate how many moles of hydrogen gas were used up. So I'm going to get my calculator out, multiply everything on the top divided by everything on the bottom. So ultimately it's going to be 2 divided by 24,500. So according to my calculation, 0.0000082 moles of hydrogen gas are used to power the propeller for 1 minute. Now, based on the table at the very beginning of this lesson, it said that hydrogen gas provides 242 kilojoules for every 1 mole of gas. Oops, I meant 1 mole of H2 there. So I can multiply by my answer here by that value, and I get 0.0198 kilojoules. Multiply by 1,000, that would be 19.8 joules of energy are required to power that propeller. So in the making sense, it says if you knew it took 4.33 milliliters of hydrogen gas to power that for 1 minute, you could set up your calculation like this. It says compare your calculation with the one that is shown here and explain any differences. Well, our calculation was the same, except we stopped and figured out how many moles it was before we did the final step of multiplying by hydrogen's value of 242 kilojoules per mole. So there's not much different. We have a different starting number, theirs was over twice as big, and then we stopped part of the way through. But otherwise, it's pretty much the same. So for the check-in questions, it says, why is it important to read the hydrogen gas column height immediately before and after a trial? And that's so you know the amount of hydrogen used only during that 1 minute of the propeller running. Otherwise, if you wait a little bit longer, then it's going to not be quite the correct number that you need. And why are we measuring hydrogen and not oxygen? Well, hydrogen is the fuel, and we're going to learn about something called the limiting reactant. Technically, there's tons of oxygen in the air too, so the thing that runs out is the fuel. And number 3 is just making another prediction based on if you did 2 trials, then what do you think your 3rd trial would look like? So are you confident in your lab values? All right, so that is what you missed in lesson 4.